of our last chapter. Yesterday already we started discussion some basic concepts of chemistry. So actually इसमें बहुत सारे topics है, छोटा छोटा करके बहुत सारा topics है. Yesterday we discussed some of them. Today second part is there, significant figures, then precision, accuracy and dimensional analysis. ये 3 टॉपिक हम लोग कवर करेंगे. अच्छे से देखो, ये जो चैप्टर है, ये चैप्टर पूरे next 2 years it will be helping you. All small concept. I hope you are preparing short notes. जितना भी कॉन्सेप्ट है छोटा छोटा करके एक नोटबुक बना लो और उस नोटबुक में एकदम कंसाइज वे में पूरा चीज लिखो. ओनली दैट हाईलाइटिंग पॉइंट, बिकॉज इन नीट एग्जाम शॉर्ट नोट इज वेरी वेरी इंपॉर्टेंट. फॉर एवरी चैप्टर यू मस्ट प्रिपेयर शॉर्ट नोट्स. ऐसा कोई टॉपर्स नहीं बना और रैंकर नहीं बना जिसके पास ये शॉर्ट नोट्स नहीं है. यू मस्ट हैव दैट short note. So now let's see what our first topic. First topic is under this scientific notation. So scientific notation means what? For example, if I have a big number, okay, very big number, if someone is asking me just write that number on the paper, 1 time 2 times, no problem, I can write. But multiple times, 10 times, 15 times, if I need to write, ये पॉसिबल ही नहीं है ना. कितना टाइम लगेगा वो एक बिग नंबर को लिखने के लिए. तो ये प्रॉब्लम को सॉल्व करने के लिए, ये ऐसा नहीं है ओनली फॉर बिग नंबर्स. इफ वेरी वेरी स्मॉल नंबर इज देयर, 0.0000, 1000 zero, after that some digits are there, every time to write that in a paper or to record that or to write in a sentence, it is not conventional, right? Lot of problem will be there. So that's why big number हो या बहुत ही छोटा, इसको एक साइंटिफिक तरीके से लिखा जाना चाहिए. that will save our time. Okay, that will be much more user friendly, we can say. So just say this, n into 10 to the power n. What does it mean? If I write one number, let's consider 0.0003. If we have this number, so just see after decimal point 1, 2, 3, 4. So we can write this 3 into 10 to the power 1, 2, 3, 4. That's why 10 to the power minus 4. Okay. बताओ, ये काम ही नहीं कर रहा है. Okay. So here 0.003, we can write this in this way, 3 into 10 to the power minus 4, right? 3 into 10 to the power minus 4. Now check, this thing I am representing in this way. So it will be much more conventional, right? It will be, we can easily write this thing. Now this is very small number. Now if I consider, let's consider 3, 0, 0, 0, 0, 0, 0 like this. So this big number, instead of writing in this way, we can write 3 into 10 to the power, how many 0? 1, 2, 3, 4, 5, 6, 7. 10 to the power 7. Easy, right? So in this way we can write. So this is our scientific notation of that big number, right? So in this way we have to write big number or small number. Format will be like this. Next, so here I have one example. So this is very small number, so 1.87 into 10 to the minus 5, like that. And this is big number, so that one also we can write. So after that, if we have lot of numbers in form of this scientific notation, like 3 into 10 to the power something, or n into 10 to the power n, this type of number if we have, how we will do addition, subtraction, multiplication and division. साइंटिफिक नोटेशन में जो भी नंबर हम लोग प्रेजेंट करेंगे वो फाइनल नंबर को कैसे एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन हम लोग करेंगे. तो ये एक रूल होना चाहिए और वी हैव टू नो दैट. So first, addition and subtraction. For example, this thing 6.65 into 10 to the power 4 plus this is one part plus 8.95 into 10 to the power 3. So here two numbers here. Scientific notation means two numbers we have and we are doing addition. How we will do that? Just now see carefully. Here we have 10 to the power 4 and here we have 10 to the power 3. Arey. Okay, 10 to the power 4 and this is 10 to the power 3. We have these two numbers. This 10 to the power 4 and 10 to the power 3, these two are not same. If we need to do summation, addition or subtraction, these both okay. बताओ. So 10 to the power 4 and 10 to the power 3, these two are different. So we have to make either ये 10 to the power 4 को 10 to the power 3 करना पड़ेगा और 10 to the power 3 को 10 to the power 4 में कन्वर्ट करना पड़ेगा. One of them. Both must be the same thing. So just see here 6.65 into 10 to the power 4, just like before previous one, and we are converting this 8.95. No need to use that. We will use manual method. Manual method is much more conventional. Okay. So here just check 8.95 into 10 to the power 3. So we are converting this 10 to the power 3 into 10 to the power 4. Correct? So if we convert this thing, so that's mean we have to divide this 8.95 by 10, right? So from this we are getting this. Now it is easy. So 6.65 and 0.895. Just these two things you have to add, which is coming 7.545 into 10 to the power 4. So this will be our final answer. Exactly same process will be in case of subtraction. Power of 10 to the power, 10 to the power that n, this 10 to the power n, this power must be same in case of addition and subtraction. Okay, otherwise mistake will be there. So this is all about addition and subtraction. Multiplication and division. If we have, I have one example. So this one, this is just formula n1 into 10 to the power n1. So this is one that scientific notation or that number, big number in form of scientific notation. So these two numbers we have. Now if we want to multiply, just check n1 and n2, this will be multiplied, and whatever power part is there, this small n1 and here small n2, since we are doing multiplication, that positive part will be here, n1 plus n2, 10 to the power n1 plus n2. Clear? Power part will be addition, you have to add power part, and that factor n1 and n2 just multiply. This is the process. This is the process. Now if you consider division, n1 into 10 to the power small n1, n2 into 10 to the power small n2, just n1 by n2 like this, and power will be subtraction. That subtraction will be there, n1 minus n2. This is the simple process. Addition, subtraction, left side, multiplication and division. So if I give 2 to 3 numbers, you have to follow this rule and you will get the answer as per question. Now I have one example, this one. Let me check, you will try to answer this question. Now see, first try to understand this question. I have this thing, multiplication, 142.06 and 0.895. 0.23. If we multiply, then we will get 32.6738. Now my question is, this 32.6738, this is the correct answer or 33? Sometimes in numerical question बहुत बार क्या होता है, वो नियरेस्ट इंटीजर पूछता है ना, नियरेस्ट इंटीजर. न्यूमेरिकल क्वेश्चंस है, स्पेशली जेई एग्जाम पे ये पूछा जाता है, बट नीट में भी ये कन्वेंशनल है कि जब भी नियरेस्ट इंटीजर पूछता है in numerical question, so how we will decide which one will be the nearest integer? So here we have this technique. Just check, if you compare these two things, after this we will study significant figures, there it will be much more clear, but pay attention here. 142.06, here number of significant figures, after some time I'll explain in detail. Just see this, how many significant figures here we have? Just count 1, 4, 2, 3, and after decimal point 2, 0 and 6. Total how many? 5. So here 5 significant figures. Right side 0.23. Left side 0, we cannot count. Only right side 0 we have to count. So here how many significant figures? 1 and 2. Now whenever we have this type of thing, two different significant figures, 5, 2, always maintain, or we have to write answer in form of least number of significant figures. So least number of significant figures here 2, right? So in answer, after multiplication we are getting this big number 32.6738, but our actual answer will be 33. Why 33? See, in 33 how many significant figures we have? Only 2, right? Only 2. Now after some time again we will discuss this type of number where we can get more than 2 also, but try to understand here 33. Now this 33 from where we are getting? From this big number. Now just check, 32.6738 we have. Here how many significant figures we have? 1, 2, 3, 4, 5, 6. Here significant figures 6, but we need 3, 33. Now your question should be, why it is 33? Why not 32? Correct? Because there 32 is written, so I can write 32 also. But no, answer is 33. Why? See, after this decimal point, more than 5 we have. This is 6, right? If we have more than 5, then it will be towards next digit. You have to consider next number, coming number. So after 6 means 32.6 means you have to consider 33. If it is 32.4, then you have to consider 32. If it is 32.4, then you have to consider 32. If it is 32.6, then you have to consider 33, like this. So how we will find nearest integer? In this way. Correct? So that's why your final answer here will be 33. That is the nearest integer. Acha, again division we have. So here 0.90 by 4.26. From this we will get this big number, this fraction 0.2112676. But what will be the 2 decimal point? Again, if you check PYQ, so many times you will see in the question it is mentioned, write your answer in 2 decimal point. Okay, 2 decimal point, 3 decimal point, or nearest integer. This type of things will be there in numerical question. So 2 decimal point. Why 2 decimal point? Just check this first one 0.90. What is the number of significant figures? Only 2, 9 and 0. Left side 0 we will not count, right side 0 we will count. So 0.90, so 2 here, number of significant figures 2. 4.26, number of significant figures 3, 1, 2, 3, right? So above 2 and bottom 3. So which one is the minimum one? 2, right? So that's why in the final answer we have to maintain 2 significant figures. So this is our exact calculated result, but in the answer we will write only up to 2, 1. Correct? Now just see here 0.211 we have. Again just check, just compare with that. 0.21 up to here we have to write. After 1 we have 1. That's why we will write only 0.1. If in any question, if you are getting 0.21, let's consider 6, which is more than 5, in that case you will write 0.22, correct? This is the way how to find that exact that significant figures or nearest integer or 2 decimal point, 3 decimal point, like this, correct now? So 0.22, this is the process. I know you might be confused little bit based on these two example. Don't worry, we have that entire slide or entire discussion based on that only. Lot of things we have to know. So from this only we have learned how to write scientific notation, means very big number or very small number, बहुत बड़ा नंबर और बहुत छोटा नंबर, जो पूरा लिखना पॉसिबल नहीं होता और कन्वेंशनल नहीं होता, ट्रेडिशनली नॉट, it is not user friendly or it is very difficult for us to read or write. So there we use this scientific notation, n into 10 to the power n, in that power form, exponential power form. So the exponential form, right? In this way we write. Now if we have this form of any number which is presented in this form, how we will do addition, subtraction, multiplication and division? So this is the process. Now at the end we discuss these two examples where we introduce one word which is called scientific figures. Scientific figure, what is that? How we are converting this 32.67 into 33, next here 0.2122, this big number into 0.21, how we are doing that thing we will learn. So first question is, what is significant? First thing is, what is significant figures? What is significant figures? So a lot of things are written. I'm just giving one example, then it will be much more clear. See, in chemistry, not only chemistry, in science, everywhere, we do a lot of experiment, right? Lot of experiment. So all those experiment gives lot of data, right? Lot of measurable values. Now, for example, I'm measuring something. Let's consider I'm measuring this pen, right? I'm using different types of scales. Using, total, let's consider 3 scales we have. Now, if first scale is measuring, this distance, this length of this pen, let's consider 9 centimeter. Another scale, let's consider 10 centimeter. Next one, third one, 11 centimeter. So different types of thing we are getting, right? Correct? So different values we are getting. So now the point is here, which one is the actual one? This is the first question. One time we are getting 9, then 10, then 11. So different types of measurable values. We are measuring different length, right? Or our values are different. So accuracy, precision, these terms will be coming in this case, right? Because we don't know. Accuracy means which is the exact one. Precision means if every time I'm getting the same thing, then that is precise, right? So these two terms also we will discuss. But here just see, significant figures means, here let's consider its actual length is 9 centimeter. Let's consider actual length is 9 centimeter. Now, if I am saying its actual length is 9 centimeter and one of my friend is saying, no, it is 9.2 centimeter. Try to understand. I am saying it is 9 centimeter, and my friend is saying 9. Let's consider 25 centimeter. Correct? Which one is more accurate? Which one is more, you can say precise also. Which one is more, that accurate one? 9 centimeter, it is not towards close, is exact number. 9.25, it is very much precise, right? It is very much precise. Now, if another friend, if he is saying 0.255, again it is giving more accurate result, correct? So that's mean every time if you see here number of significant figure 1, next one 9.25, total 3 digits, so that's the number of significant figure 3. Third example 9.255, number of significant figures there 4. So if number of significant figures increasing, that means we can trust that number. Trust will be increasing, means exact. I'm saying exact thing, right? When that exact number or exact thing we are saying, that means we can trust that. That is certain value. That is certain. Uncertain means, okay, means it is 9 centimeter. It may be 9.1. It may be 9.2. It may be 9.3. Why? Because just now I said, na, if you say 9.1, nearest integer 9. If you say 9.2, nearest integer 9. Correct? If you say 9.3, nearest integer 9. So every time, if you consider all this thing, nearest integer 9. So that's why this 9 is having less accuracy or less trust than this 9.25, because 9.25 is, giving exact thing. Again, if you consider 9.255, it is giving much more, trustworthy result, means that is giving much more exact value. So that's why whenever we increase the number of significant figures, this, by the way, this is called significant figures. How many digits are there which is giving that trustworthy result or exact thing, exact value, certain value. This word is much more appropriate, certain. Okay, the जितना ये नंबर बढ़ेगा, सिग्निफिकेंट नंबर्स का ये जो डिजिट्स और सिग्निफिकेंट नंबर ऑफ सिग्निफिकेंट फिगर, ये जितना ज्यादा होगा उतना ही ट्रस्ट बढ़ेगा वो नंबर के ऊपर. सो ग्रेटर द नंबर ऑफ सिग्निफिकेंट फिगर्स, स्मॉलर इज द अनसर्टेनिटी, मींस अनसर्टेनिटी कम होगा, मींस सर्टेनिटी ज्यादा होगा. नेक्स्ट थिंग, ऑलवेज रिमेंबर, ये जो सिग्निफिकेंट फिगर्स है, last digit, it is always uncertain. I'm giving example. So last digits always uncertain. Why? Just check. If I say 9.126, correct? 9.126. How many significant figures we have here? 1, 2, 3, 4. Correct? Only 4. Next, this thing we can write in this way also. 9.13. Just now we have seen, na? After 2, 6 we have. 6 is more than 5. Means 26. Simple question. 26 is closer to 20 or 30? 26 is closer to 20 or 30? Obviously 30, right? Because it is more than 25 means towards 30 less number you need, right? 20, 30 and 26. 26 will be closer to 30. So that's why this 26, let's consider 0 is there and just imagine 0 is there. Okay, 30 we are writing, correct? So 9.13 we are getting. So just now you just try to understand. Here the last digit, if you consider this one, last digit is 6. But there we're not giving any 6 number, right? Correct, na? So always, that's why whenever we consider significant figures, last digit, it is not certain, it is uncertain. Okay. Acha. Next, whatever I discussed, examples I gave this one, we have certain rules. Total 6 rules we have. Let's consider one by one. How we will find out number of significant figures? If I give a lot of numbers, set of numbers I am giving, for each number, how we will find out number of significant figures? So there are certain rules. First of all non-zero digits are significant. All non-zero digits are significant. That's mean, let's take one example. This one. There is no 0, right? No 0. There is no 0. So 42.3, how many digits we have? Total 1, 2, 3. That's why significant figures will be 3. Correct? Next one, 1, 2, 3, 4. How many digits you can see? 4. That's it. Only you have to count number of digits. That's all. Very easy, right? Only you have to count number of digits. Very easy. Next one, A non-zero, a zero becomes significant figure if it appears between two non-zero digits. Let's take one example, this one. See here 0 is present, left and right both are non-zero digit, 5 and 3, right? So in that case we have to consider that 0 also. So just count 1, 2, 3. That's why significant figure will be 3. Next example, 1, 2, 3, 4. Significant figures will be 4. Very easy. So whenever 0, see all non-zero you have to count. If 0 is present between two digit, between two non-zero digit, then we have to count that 0. Simple thing. Now see this example, this thing, leading 0 or the zeros placed to left side, this one. Just check this example, then it will become very easy. Instead of reading all of that, if you see these examples, it will give much more clarity. 0.543, 0.543. Left side 0, we don't count. Left side 0, you should not count. Only right side part, just check. 1, 2, 3, answer is 3. Again check, left side 2 zeros are there, don't consider. Only right side these 2 digits, so that's why answer is 2. Left side 0, we will not consider. Acha, fourth one, just take one example. Right side 0, this is the most important thing because you will be confused after this 4, 4, 5, 6. These 3 rules, their chances high that you will be confused. 1, 2, 3, very easy. Non-zero digits. If you find non-zero digits, just count them. That will be your answer. Number of significant figures will be that number. If 0 is present, and if 0 is present between two non-zero digit, then count that 0, no problem. But when 0 is present before that non-zero number, like this one, do not count. Decimal point is there or not, it does not matter. Left side 0, always you have to ignore, correct? Do not consider that left side 0. Now if it is in the right side, after decimal point, you have to count. There is no way that you can ignore. Right side 0, always you have to consider. Now just check first example, 1, 2, 3, 4. So number of significant figures will be 4. Last mein dekho 1, 2, 3, 4, 5. So significant figures will be 5. So left side 0, we will not consider. Right side 0, yes, we have to consider. If decimal point is there, so that exact number, just that exact number of digits you have to count, and that will be your answer of number of significant figures. Now another 2 rules we have, just check. If you see example, it will be much more clear. Just check this one. Just now I said, if zeros are present on the right side, then you have to consider, in case of decimal point, exact number of digits, 0 and non-zero, count those digits and that will be your answer. But point is, if you have this type of number 11400, there is no decimal point, right? There is no decimal point. If you consider 114.00, your answer will be 1, 2, 3, 4, 5. Exactly 5. There is no change in answer. 114.00 means your number of significant figures will be 5. There is no change, no doubt in this answer. But अगर ऐसा हो जाए कोई decimal point है ही नहीं, then क्या answer होगा? In that case we have option. In this case we can have 3, means non-zero digit you have to count. That is the minimum one. So here number of significant figures can be 3. If you consider one more digit, then 4. If you consider next 0 also, then 5. So in this case 3, 4, 5, all these 3 can be your answer, right? So here 3, 4, 5 all are possible. This is a rule. If there is no decimal point, and zeros are present on the right side, so you may consider or you may not consider those zeros. Okay, so here number of significant figures, that answer will be varying. It can be 3, 4, 5, all are correct. Next, if you write this 11400 in terms of scientific notation, which one that? That 1.14 into 10 to the power, 1.14 into 10 to the power 4, like that, like this. So in this case, what will be your number of significant figures? Ignore this part, do not consider this part, just consider this one. 1, 2, 3, that's why answer will be 3. And if you consider in this way, we are adding one more zero. Remember, decimal point and right side 0, you have to consider 1, 2, 3, 4. So here number of significant figures will be 4. So this is fifth one. And sixth one, this is very interesting. If we have exact number, or let's consider 2, there we have 2 or 20. In this case, what will be the number of significant figures? So this 2, we can write, someone can write 2.0 or 2.000, anything you can write, you can add, you can write in that way, right? So in this case, number of significant figures will be varying, right? There is no specific number, there is no specific number. In case of 20 also, you can write in this way, you can write 20.0000 like this. So there is no ending. Similar to this 11400, here also the same picture will be there. There is no ending of number of significant figures. Okay, so anything you can get. If you consider pi, if you represent 2 in terms of 2.00, so here number of significant figures will be 3. So in this case, count all of them, so that will be your number of significant figures. Pi, what is pi value? 3.14, or a lot of numbers, digits are there, right? So that's mean there actually we have infinite number of significant figures. So this is all about how to calculate, how to find number of significant figures. Total 6 rules we have. So especially that zero related thing, after decimal point, if zeros are there, you have to count. If there is no decimal point, still zeros are there, then flexible, means number of significant figures can be varying, like this example. Okay, if zeros are present left side before non-zero digits, then we cannot count. If zeros are present before this, just check the already, just these examples already I discussed. I am repeating the same thing because these are rules we have to discuss, then only we can remember. There is no other way. So zeros before number, like this. Third rule, just put star mark. If zeros are present before non-zero digits, we will not consider. उसको एकदम consider नहीं करना है. Okay. So third rule, fourth rule, and this is fifth rule. These 3 rules are very, very important from exam point of view. Okay. Achha, now next, let's go to the next topic. Okay. Achha, rules ho gaya. Next, this one. Yes. Now how we will do round off. Already I discussed first slide. Whenever some big numbers are there, right, decimal point is there, then how we will find out nearest integer? How we will find out nearest integer? So here we have this. Just check. So many rules are there. Again, if you read these rules, it will be very difficult to remember. So see examples, and you must write example on your short note. So how we will do? How we will do round off or rounding off this technique? Okay, you have to do round off to 2 decimal point or 3 decimal point, or you have to get the nearest integer. How we will do? Here we have example 1.386. Now in the question they are asking we have to write this in 3 significant figures. Here how many significant figures we have? Already we know there is no 0, that means there is no confusion. Just count number of digits, non-zero digits. 1, 2, 3, 4. There is no confusion here. 4 significant digits are present. Now क्वेश्चन में क्या पूछा है? मुझे 3 डिजिट वाला 3 सिग्निफिकेंट फिगर्स वाला नंबर चाहिए. तो इसको कैसे कॉम्प्रेस किया जाए? जस्ट चेक this 8 up to 8. Now 8 will remain as 8 or it will change. Again, just see from this perspective. Consider 86. Now 86, it is closer to 90 or it is closer to 80. 86, just in this way it will be easy to understand this thing. 86 is closer to 86, 80 or 90. "86 is closer to 80 or 90. Easily you can answer, right? It is close to 90, and just do not consider that is 0. So wherever this 86 is there, instead of that just write 1.390 and do not consider this 0. Then that will be your answer. This is the easiest method. There is no confusion. But there is a problem. What problem? If you consider, here also I think same thing. Here we have one important thing. Just check. Here we have 4 significant figures, and now again we have to consider 3 significant figures. Now here it is 34. Same logic like before. 34, it is closer to 30 or it is closer to 40. 34, it is closer to 30 or it is closer to 40. By default you have to consider 30, right? So instead of 34, just write 30, means 4.340, and do not consider this 0, and you will get this answer, 4.33. No doubt. First and second, no doubt. Only you have to consider which one is closer to the number, 30, 40 or there 80, 90, like that. Now last one, this is the important one, and most of the cases you will do, most of the students do mistake in this case. If it is like this problem, 6.35. Now how many significant figures here we have? 3. In the question it is given that you have to convert that into 2 significant figures. Now this 6.35, it will be 6.4 or it will be 6.3. Which one will be the correct answer? Because as per this previous one, I said here we have 35. 35 is closer to 30 or it is closer to 40. बोलो 35 ये 30 के क्लोज में है या 40 के क्लोज में है? You will say, sir, how can you say this type of nonsense question? Why? Because it is the middle point. It is not closer to 30 as well as it is not closer to 40. It is in the middle point. So here we have to decide. Check this 30. 30 is even number or odd number? Sir, this is odd number. Whenever we have odd number, we have to convert that into even number. And in that case, we have to add 1. So this 3 will become 4. So that's why this 3 will become 4, right? So we will write 40. So do not consider this 0 and your answer will be 6.4. But instead of 35, instead of this odd number, if it is even number, second example, 6.25. 6.25. So here you check again the same story. 25, it is in between, exactly at the middle point between 20 and 30, right? This is the middle point. Now which one you will consider, towards 20 or towards 30? Here the concept is this 2 is even number, right? Whenever we have even number, we will not change that. In this case, whenever this 5 is there and before that we have even number, we will not change the even number. So that's why answer will be 6.2. This is the most important part in this round of technique. Okay, so here whenever we have odd number and पास में वो 5 है, odd number को even करना है और थोड़ा सा increase करना है, or if it is even number, do not change. That will be your answer only. Okay, 6.25 to 6.2 and 6.35 to there 6.4. So this is the important part. This, especially this last one, very very important, this C point, because other two everyone can manage that. Okay, everyone can manage that. So I have one question, just try to solve this. If I ask you, just write 5.9082, convert that into a two significant figures, what will be your answer? How we will convert that into two significant figures? So here how many significant figures we have? 1 2 3 4 5. I'm asking you have to write this into two significant figures. How we will write? So that's mean I have to consider up to 9, correct? So up to 9, check 9 के बाद क्या है? 0. So we will not consider. Answer will be 5.9. This will be your answer, correct? Now if I ask you, just write the same from this number, just write in form of three significant figures. How we will write? Okay, so three significant figures means up to 0, and there after 0 we have 8. 8 is more than 5, so it is easy to decide, right? So that's mean easy to decide means this 8, this 2 means consider 8. 8 is closer to 10 or it is closer to 0. Which one will be your answer? 0, 8, it is closer to 0, 0 or it is closer to 10? Obviously it is closer to 10. So that's why instead of 0, 8, we will write 5.910, right? 5.910, and I said do not consider that 0 because we assume that. So 5.91. So this will be our answer, correct? So this way, in this way, we have to find out how to, what will be the rounded off number, rounded off figure. Okay, up to here I hope it is clear. So till now we have discussed that scientific notation, that part, addition, subtraction, multiplication, division, and here significant figures, that calculation of number of significant figures, and how we do round off. Okay, nearest integer or nearest 2 digits, 3 digits, like that. So that part is done. Next, if we have lot of that scientific notation, that number, lot of fractions, and in the question they are giving lot of addition, subtraction, division, multiplication. So after that operation, after those operations, what operations? Addition, subtraction, division, multiplication, all of that, whatever number you are getting, how we will concise that? What will be your final answer? In form of 2 significant figures, 3 significant figures, like that. We are going to discuss that part. Just check one by one, and here always you have to remember least number of significant figures we have to consider. Means if we want to do addition, so this is one number, this is another number, you have to count in which case minimum number of significant figures we have. Your final answer must have that minimum number of significant figure. This is the final answer for all of these operations. Now just check one by one. So here addition, so we are doing addition. So we have these three numbers, 1, 2, 3. Everywhere if you count a number of significant figures, just check here how many? 1 2 3 3, 1 2 3 3, 1 2 3, here also 3. So everywhere number of significant figures 3. Now once you add all of this number, you are getting this big number 36.723. Now just tell me, is this the correct answer? Because if you check in the first part, what is the minimum number of significant figures? 3. Everywhere we are getting 3, right? So your final answer there, it must contain only 3 significant figures. Here how many we have? 1, 2, 3, 4, 5. We don't want 5, we want 3. So that's mean we have to do round off, that technique. So how we will do that? Round off means up to 3 means up to 7 we have to consider, right? Up to 7 we have to consider. Now this 2 we have, 2 is less than 5, right? 2 is less than 5. So that's why no need to change anything. Only 36.7 will be your correct answer, right? 36.7 will be your correct answer, right? Easily we can answer this. Next, multiplication. So we have this 2 number, 142.06 and here 0.23. So here how many significant figures we have? 1, 2, 3, 4, 5. इधर में 5 है और इधर में 2 है, right? So that's mean final answer में कितना number of significant figures होना चाहिए? 2. But after calculation we are getting this. So we have to concise, we have to convert this into a number having 2 significant figures. So here just check 32.67. After this 2, this entire part will be removed, but before going, somehow it will influence this 2. You just tell me, again the same logic. You need up to second digit, so consider 26. 26, it is closer to 20 or it is closer to 30. You will say, sir, what you are saying, it will be closer to 30 only. So then write 3, 2.6, I'm just changing this into 330, right? And I'm not, decimal point is there, and always I said, whenever we convert in this way, do not consider 0 because we assume that. So 33 will be your answer, right? So 33 will be your answer. So whenever in numerical question we do calculations, we have to follow this thing. Otherwise, whenever you will match with the answer key, and you will imagine, sir, I calculated in that way and I gave that exact value, but in the answer key there is something, nearest digits or something else is there, right? Little difference is there. So in that way, that's mean you didn't study in that case. Always you have to follow this addition technique. What will be the final answer? So here if you write 36.723, that is not the accepted answer. Here accepted answer will be 36.7 because in the question minimum number of significant figures are 3. So now subtraction. Check another example, subtraction. So when you subtract these two numbers, you will get exactly this thing, but this is not our answer. Because if you consider first one, how many significant figures we have? 1, 2, 3, 4, 5. Here 5. And here 1, 2, 3, 4, 5, 6. So that's mean minimum number of significant figures 5. So answer 1, 2, 3, 4, 5, 6. Here also 6. We have to convert that into 5 significant figures. So 1, 2, 3, 4, 5. Now just check 8 को remove करना है. But before going, it will influence in some way. 8 is more than 5, right? So that's why add 1. Your answer will be 38.282. 1 will become 2 because 8 is more than 5. Correct? So this is our answer, 38.282. Clear, na? 38.282. Okay. Next, last one, division. 0.90 you are dividing with 4.26, and after that you are getting exactly this number 0.2112676, but this is not our accepted answer. First part here number of significant figures 2, and second part 4.26 means 3. Minimum number of significant figures here 2, so we have to maintain this 2, and just check 0.21, right? Left 0 we don't consider, so answer will be 0.21. Why? Because next 1, This 1 is less than 5. Less than 5 means we will not consider. So answer will be 0.21. 0.21. So this is all about addition, subtraction, multiplication and division of maintaining this scientific this figure. Okay, let's consider next part, precision and accuracy. Now what do you mean by precision and accuracy? There are a lot of definitions. If I tell this definition, you might be confused, but if you see this picture, it will be very, very clear to you. Now just see, first picture, here this is our target, right? This is our target. This is our target. Now measured value and actual value, two things we have. Always remember, let's consider, I gave, before, when I started this class, I said that we are measuring length of this pen, remember? So after measuring, 3 times I am measuring, right? One time I am getting 9, second time I am getting 10, third time I am getting 11. And its actual length is, let's consider 10. Its actual length is 10, but I am measuring the length of this pen is 9, one time, second time 10, third time 11. So if I do average, 9, 10, 11, average will be 10, correct? 9, 10, 11, if you do average, you will get 10. So this average value, it is matching with its actual length, which is 10. So that's mean my result is accurate. My result is accurate. But during measurement, one time I got 9, second time 10, third time 11. So difference is there, right? So that's mean it is not precise. So precision means, closeness of measured value, closeness of measured values. And accuracy means closeness to the actual value. So just in simple way, you have to write precision means, it is not coming properly, no? Closer to, here just write closer to each other, all the measured value. Closer to measured values, okay? And accuracy means closer to true value, closer to true value. Okay, these two are the thing. Now see this diagram, this picture. Now check, this is our target value and these are all measured value. See, all measured values, they are actually very close to the target, right? Which is actual value. So that's why it is highly precise and highly accurate. Second example, you just check, this is our actual thing. Actual value is here and we are getting a different place, right? But all these measured values, they are very close to each other, but they are away from the true value. Try to understand here, all measured values, they are close to each other as well as they are close to the actual value. That's why highly precise, highly accurate. Here all the measured values, they are very close to each other. That's why high precision. So precision means closeness among the measured values. Precision means closeness among the measured values. So here all measured values are close. That's why highly precise. But it is away from the target value or true value. That's why it is having lower accuracy. So accuracy means, always remember, accuracy means the difference or the gap, longer gap between actual value and your measured value. Now third point, you just check, we are getting random numbers, random measured values. So what does it mean? If you consider all of these, it is not even closer to the true value, and all these measured values, they are also not close to each other. All are random. So that's why it is having lower precision and lower accuracy. Okay. both are very low in this case, both are poor. So now I hope the idea is clear. What do we mean by precision and what do we mean by accuracy? Next, I have one data. Just try to answer this. This experimental data we have. Some experiments we have done. Let's consider experiment number 1, 2, 3 and A, B, C, D. These are the sets. Means total 3 times we are getting. So 4 cases we have. 4 cases, and every time we are doing the same experiment 3 times. Now you have to consider, you have to say which one is more accurate, more precise, right? These 2 things you have to say. And average value, if you do average 9.9, 10, 10.1, if we do average we are getting 10. So already average values are given, and the most important, true value is also given. True value, which is real value, this is real, exact value, it is also given. Now you have to consider, you have to say first cases, what is the level of its accuracy, good, bad, like that, poor or good. Poor accuracy means very, poor accuracy means true value and measured value gap is there, huge gap is there, huge gap is present between true value and measured value. Poor accuracy, poor precision means everywhere in all experiment we have different value. Just see this first cases. First consider this first case A. Here average value 10 and our true value also 10. So that's mean it is highly accurate, right? It is highly accurate, means good accuracy. And if you consider all this data, 9.9, 10, 10.1, these are very close, right? 9.9, 10 and 10.1, this is very close to each other. That's why first case, high accuracy and highly precise, or you can consider good accuracy and good precision. Just consider that good or poor, that terminology. So first case, good accuracy and good precision. Second example, now case B, 9, 10, 11. So huge gap is there, right, among this measured value. So by default we can say poor precision. But if you consider average value, which is 10, it is exactly with true value. So that's mean good accuracy. So second case we will get good accuracy and poor precision. Third case, just check 8.9, 9, 9.1, means measured values, they are very close to each other. That's mean good precision. So here good precision we have, but if you consider this average value, it is 9. But हम लोगों के पास 10 is the accurate one, na? Means true value. So gap is there. So that's why it is poor accuracy. Correct? Last one, 8, 9, 10. Huge gap is there among measured values. That's why poor precision. And if you consider 9, average value 9 and our actual value is 10. So between them also gap is there, right? So that's why poor accuracy. Check the final answer. So we have got this thing. Just check, match with this. First one, good precision, good accuracy. Second one, poor precision, PP, and good accuracy, J. Okay. Next, good precision, GP, and poor accuracy, PA. And here poor precision, PP, and poor accuracy, PA. Okay, so this is the way to identify which result, which data is much more accurate, which one is much more precise. So we have to understand whenever gap, if all the measured values, they are very close to each other, highly precise. If average of all the measured values are very close to the true value, highly accurate. If any gap is there, that difference is there, big difference is there, then poor, right? So this is the idea of this. Next, dimensional analysis. This is very, very important, because based on this we can find out the unit. What unit? Unit of different parameters. If in any equation, left side and right side unit must be the same. In any equation, left side and right side unit must be the same, and that will be confirmed by this dimensional analysis. So it is just definition. It is used to check the correctness of physical equations, convert units, and derive relations between physical quantities. Now this is the important thing: fundamental quantities and dimensions. So mass is represented by capital M, length capital L, time capital T, then temperature theta, then I electric current, then number of amount of substance N. You have to remember at least these three, mass, length and time. You must remember these three: mass, length and time. In chemistry field, in chemistry we need these three things. Okay, now just let's find out some dimensions. Acha, here we have this: velocity, acceleration, momentum, force and pressure. How we will find out their dimensions? Just check. First one, velocity. What is the formula? Distance divided by time, right? Distance divided by time, or small t we can write. Now distance means it is a length. Distance means it is a length, and we know length means L. Now time means we represent that in second, right? S. So that's why L second inverse. This will be our answer. This should be our answer. Next, acceleration. Acceleration means velocity per second, right? Change in velocity per second. So that is the thing. And here velocity already we have. For velocity, L second inverse. So L second inverse divided by second. So what you will get? You will get L second inverse 2, correct? Let's check the answer. So first one, sorry, one mistake I have done here. It is not second. Already I said that time is represented by T, capital T. So that's why, sorry, this, just check. This is length, by time is represented by T. So that's why LT to the power minus 1. Achha, acceleration. So it will be velocity change divided by time, right? So velocity already we got LT to the power minus 1 divided by time means T. So LT to the power minus 2. LT to the power minus 2. Next, momentum means mv, right? Momentum means mv, and mass is represented by m, capital M, and v is represented by LT to the power minus 1. So this will be our answer, ml to the power minus 1. And always we have to write these dimensions within third bracket. Next, force. Sorry, force means, what is the formula? Already we know in physics, right? Force means F equal to ma, mass into acceleration, and mass already we know m, and acceleration already we calculated L t to the power minus 2. So this will be our answer, ml to the t to the power minus 2. Pressure means already we know pressure means force per area, right? Now for force already we know ml t to the power minus 2 divided by area means length square. So L square. What we will get from this? M L to the power minus 1 t to the power minus 2. So this is the answer. So till now already we have completed these things, precision, accuracy, then scientific notations, then this dimensional analysis. This, this is the way. And if you have understood all of this, and if you have written all this in form of notes, I hope you can solve all these questions based on these topics. So we have next some few things we have. So here we have Telegram channel, so you can join this channel. So here a lot of updates you can get if we upload any video, so immediately you will get a notification there. So join this Telegram channel, it will be helpful for you. And this is our YouTube channel, so we are doing a lot of lives, we are taking live classes, so day by day it will be much more engaging. So if you subscribe and if you follow this, it will be helpful for you. So subscribe and always that press this bell icon, so that every day we are taking class in this evening session for 11th and 12th NEET. So right now 11th and 12th NEET, so we're planning to start JEE also, and for NCERT session also. So follow this channel, it will be helpful for you. Okay, so thank you very much. Just we will upload a lot of DPPs in our Telegram channel. Okay, in a lot of links will be provided in the description part. And okay, just follow this, it will be good for you. Thank you very much. Okay, पहले 10 मिनट पे वो लगाया था ना ये वाला